The hydrophone operator aboard HMS Starling heard it first. A faint mechanical hum, rhythmic and deliberate, cutting through the ambient noise of the Atlantic on the afternoon of February 19, 1943. The sound was unmistakable to trained ears. Diesel engines running submerged, pushing a U-boat through the water at depth. Commander Frederick John Walker, standing in the operations room of his sloop, studied the plot as his team worked to triangulate the contact. The submarine was deep, far deeper than most boats operated. His ASDIC operator called out ranges and bearings while Walker calculated intercept courses in his head. Walker was no stranger to U-boat hunting. By February of 1943, he had already sunk several German submarines and developed tactics that would become standard throughout the Royal Navy's anti-submarine forces. He understood the psychology of U-boat commanders, how they thought, where they ran, how deep they believed safety lay. This contact was behaving exactly as Walker expected, diving deep, going quiet, hoping to slip beneath the killing zone of British depth charges. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. Walker's crew prepared their weapons. Depth charges were rolled into position on the stern rails. Settings were checked and rechecked. The charges themselves were simple devices, cylindrical drums filled with 300 pounds of amatol explosive, designed to detonate at predetermined depths. The standard charges carried by most Allied escorts in early 1943 had maximum depth settings of 500 feet. Most captains set them shallower, between 150 and 300 feet, where doctrine suggested U-boats typically operated. But Walker had intelligence that suggested German submarines were diving deeper than previously assumed. Reports from other encounters, fragments of information from interrogations, technical analysis of recovered equipment, all pointed to U-boats capable of reaching 600 feet or more under emergency conditions. Walker had requested and received modified depth charges capable of reaching those depths. His crew had trained with them for weeks. The U-boat commander below had no way of knowing this. He had made his calculations based on experience accumulated over years of combat operations. He knew British depth charges rarely reached below 500 feet. He knew that at 600 feet, his boat would be strained to its engineering limits, but relatively safe from surface attacks. He had survived multiple depth charge attacks by diving deep and staying quiet. The technique had worked before. He had every reason to believe it would work again. Walker gave the order to commence the attack. HMS Starling moved into position. Engines throttled back to maintain ASDIC contact while closing the range. The crew worked with practiced efficiency. When the moment came, Walker ordered the release. Depth charges tumbled from the stern rails, splashing into the grey Atlantic water. They sank rapidly, their hydrostatic pistols counting down the pressure as they descended towards 600 feet. The submarine that HMS Starling was hunting that February afternoon represented the culmination of 2 decades of German naval engineering and tactical doctrine. The U-boat force, the Unterseebootwaffe, had been rebuilt from nothing after the Treaty of Versailles banned Germany from possessing submarines. Throughout the 1920s, German designers worked covertly, establishing submarine design offices in the Netherlands and Finland, maintaining expertise that would prove invaluable when rearmament began in the 1930s. The Type 7 U-boat, which constituted the majority of Germany's submarine force by 1943, was a direct descendant of these clandestine development programs. The Type 7C, the most common variant, was 767 feet long with a beam of 20 feet and a surface displacement of 769 tons. The pressure hull was constructed of rolled steel plates, welded together and reinforced with frames spaced throughout the hull. The design pressure depth, The depth at which the boat could safely operate for extended periods was officially 220 meters, approximately 720 feet. German submarine doctrine emphasized diving capability as a primary survival mechanism. U-boat commanders were trained to understand their vessels' depth capabilities intimately. They knew that British and American depth charges of the early war period rarely detonated deeper than 400 feet. This knowledge shaped tactical thinking. When attacked by surface escorts, the standard procedure was to dive deep, go silent, and wait for the attackers to exhaust their depth charges at shallower settings. The psychological element was crucial. U-boat crews lived in constant awareness that they were sealed inside a steel tube beneath hundreds of feet of water. The hull creaked and groaned under pressure. Rivets wept tiny streams of water that crew members monitored constantly. Electric motors hummed as the boat maneuvered at slow speed to avoid detection. The air grew stale and thick with carbon dioxide during extended submersion. Men breathed shallowly, conserving oxygen, knowing that surfacing to refresh the air might mean detection and death. Training emphasized confidence in the boat's engineering. Crews were taught that German construction standards were superior, that their submarines could dive deeper and endure more punishment than Allied designers believed possible. This confidence was not entirely misplaced. German pressure hulls were indeed well constructed, using high-quality steel and precise welding techniques. The boats could survive depths that would crush vessels of inferior construction. By early 1943, this tactical doctrine had been validated through hundreds of encounters. U-boat commanders routinely dove to 500 feet or deeper when under attack. They survived. The technique worked. It became ingrained in tactical thinking, a fundamental truth. Dive deep enough, and the depth charges cannot reach you. The explosion patterns would dissipate harmlessly above, the pressure waves weakening with distance. This belief system was reinforced by German naval intelligence, which tracked Allied anti-submarine capabilities carefully. Intelligence reports confirmed that standard British depth charges had maximum settings around 500 feet. American depth charges appeared to have similar limitations. There was no indication that the Allies had developed weapons capable of reliably reaching 600 feet or deeper. What German intelligence failed to detect was the Allied response to exactly this tactical adaptation. The Allied development of deeper-setting depth charges emerged from operational necessity and careful analysis of combat reports. Throughout 1942, escort commanders reported encounters where U-boats simply disappeared after diving. ASDIC contact would be lost at extreme depths. Depth charge attacks produced no visible results, no debris, no oil slicks, no evidence of damage. The submarines escaped. British and American naval analysts studied these reports methodically. They interviewed escort commanders, reviewed ASDIC logs, examined the performance characteristics of existing depth charges. The pattern became clear. German U-boats were diving deeper than Allied weapons could effectively engage. The tactical advantage had shifted to the submarines. The technical challenge was substantial, but not insurmountable. Depth charges detonated using hydrostatic pistols, pressure-sensitive mechanisms that triggered at predetermined depths. Increasing the maximum depth required stronger pistol mechanisms capable of withstanding greater pressure before firing. The explosive charges themselves needed reinforcement to prevent premature detonation from pressure alone. The whole assembly had to sink quickly enough to reach extreme depths before the submarine could maneuver away. British ordnance engineers at HMS Vernon, the Royal Navy's torpedo and anti-submarine warfare school, began development work in mid-1942. American engineers at the Naval Ordnance Laboratory pursued parallel development. Both programs prioritized speed. Every month of delay meant more U-boats escaping destruction by diving deep. The British Mark VII depth charge, introduced in limited quantities in late 1942, could be set to detonate at depths up to 700 feet. The weapon retained the basic cylindrical shape of earlier models but incorporated strengthened hydrostatic pistols and reinforced casings. Each charge still contained 300 pounds of amatol, sufficient to rupture a submarine's pressure hull at close range. The American Mark IX depth charge, entering service at roughly the same time, had similar capabilities. American engineers opted for a teardrop shape that sank faster and more predictably than cylindrical designs. The Mark IX could reach 800 feet, deeper than any known U-boat operating depth. Distribution of these weapons to operational units proceeded gradually. Production capacity was limited initially. Escort vessels received priority based on their operational areas and the intensity of U-boat activity they faced. Commander Walker's 2nd Escort Group, operating in the North Atlantic where U-boat activity was heaviest, received early allocation of Mark VII depth charges. Critically, the Allies maintained operational security around these developments. U-boat commanders were not informed through intelligence channels that depth charge capabilities had changed. German naval intelligence continued to assess Allied anti-submarine weapons based on earlier models. The assumption that diving to 600 feet provided safety remained unchallenged in German tactical doctrine. This information asymmetry created conditions for a profound tactical shift. German U-boat commanders would continue using tactics that had proven successful throughout 1941 and 1942, diving deep to escape depth charge attacks. But the weapons they were diving to escape had changed. The safe depths they calculated their survival upon were no longer safe. The psychological impact of this shift, when it became apparent, would be devastating. U-boat crews depended on depth as their primary defense. The knowledge that their steel hull protected them at extreme depth provided crucial psychological comfort in an environment defined by claustrophobia and vulnerability. When that protection proved illusory, when depth charges began detonating at 600 feet or deeper, the psychological foundation of U-boat operations would fracture. The Type 7C U-boat that Commander Walker was hunting carried a crew of 44 men in a pressure hull that measured just over 200 feet in length. The interior was divided into compartments, each serving specific functions. Forward was the torpedo room, where 21 men lived among the spare torpedoes, sleeping on bunks that folded up when the weapons needed to be loaded into tubes. Amidships was the control room, the operational heart of the boat, containing the diving plane's controls, the periscope wells, the chart table, and the maneuvering station. Aft were the diesel engine room, the electric motor room, and the stern torpedo compartment. The boat could reach speeds of 17 knots on the surface, using its twin diesel engines. Submerged, running on electric batteries, maximum speed was 7.5 knots, sustainable for only short periods before battery depletion forced surfacing. At economical underwater speeds of 2 to 4 knots, the boat could remain submerged for approximately 24 hours before air quality deteriorated to dangerous levels and battery charge dropped critically low. Diving procedures followed strict protocols. When the alarm sounded, crew members moved to designated stations. The commander called out the target depth. The chief engineer supervised the flooding of ballast tanks, while plainsmen adjusted diving planes to maintain the desired angle of descent. A Type 7C could crash dive from surface to periscope depth approximately 60 feet in 30 seconds. Reaching 200 feet took roughly 90 seconds. Diving to maximum operational depth of 700 feet required careful management of trim and descent rate to avoid exceeding safe limits. The pressure hull itself was the critical survival element. Constructed of steel plates ranging from 18 to 24 millimeters thick, the hull was designed to withstand external pressure of up to 10 atmospheres, equivalent to approximately 300 feet of depth. Below design depth, the safety margin decreased rapidly. At 600 feet, external pressure reached approximately 18 atmospheres. At 700 feet, it exceeded 20 atmospheres. The hull groaned audibly under such loads. Welds strained, plates flexed microscopically. Any weakness in construction, any flaw in materials, any damage from previous depth charge attacks, all became potentially catastrophic. German submarine commanders understood these engineering realities intimately. They knew their boat's limits. They also knew that those limits provided protection against Allied depth charges, which rarely functioned below 500 feet. This knowledge shaped survival tactics. When ASDIC contact was established and escort vessels closed for attack, the standard procedure was immediate deep dive. The commander would order "Auf tiefer gehen," go deep. The boat would angle downward, electric motors pushing it towards 600 feet or beyond. During the descent, the crew worked in near silence. Speaking was minimized. Unnecessary movement ceased. Equipment was secured to prevent noise. The boat's speed was reduced to minimize propeller cavitation, which created distinctive sounds detectable by Allied hydrophones. Men monitored depth gauges, watching the needles climb as external pressure increased. They listened to the hull, evaluating each creak and groan, distinguishing normal stress sounds from dangerous structural complaints. The psychological experience was profound. Every man aboard understood that survival depended on the integrity of welded seams he could not see, on the quality of steel plates he could only trust, on engineering calculations made by designers he had never met. The darkness was absolute except for dim red lighting that preserved night vision. The air grew heavy and stale, thick with the smell of unwashed bodies, diesel oil, and the metallic tang of recycled atmosphere. Time distorted. Minutes stretched into subjective hours as the crew waited, listening for the sounds that would tell them whether they would live or die. Those sounds were depth charges detonating heavy, concussive thuds that transmitted through water and hull steel with terrifying force. Even distant explosions produced shock waves that rattled equipment and shook men to their bones. Close explosions were catastrophic events that could rupture hulls, shatter gauges, and kill through pressure wave alone. Commander Walker's tactical approach to anti-submarine warfare differed from standard Royal Navy doctrine in crucial respects. Where most escort commanders relied on single-ship attacks, Walker developed coordinated group tactics. Where standard procedure called for rapid depth charge attacks, followed by breaking contact, Walker emphasized persistent prosecution. He understood that killing U-boats required patience, multiple attacks, and systematic elimination of escape options. His second escort group consisted of 6 sloops, purpose-built anti-submarine vessels displacing approximately 1,400 tons each. Sloops were slower than destroyers but had greater endurance and carried more depth, charges typically 70 to 100 charges per vessel. This ammunition capacity allowed sustained attacks over many hours, wearing down submarine batteries and crew endurance. Walker's innovation was the creeping attack technique. When ASDIC contact was established, Walker would position one sloop directly above the submarine to maintain continuous contact, while other sloops maneuvered for depth charge attacks. The directing ship would guide attacking ships onto precise coordinates, compensating for the submarine's movement and the time delay between weapon release and detonation. This technique dramatically improved accuracy compared to single-ship attacks, where the attacking vessel lost ASDIC contact as it passed over the target. The afternoon attack on February 19th followed this pattern. HMS Starling maintained contact, while HMS Kite maneuvered for the first attack run. Walker studied the plot, noting the submarine's depth estimated at 550 feet, based on ASDIC returns. He ordered Kite to set depth charges for 600 feet, deeper than the submarine's current position, anticipating that the U-boat commander would dive further when he heard the attacking ship approaching. Kite's crew set the charges according to Walker's instructions, adjusting the hydrostatic pistols on each Mark 7 depth charge. The settings were verified twice, 600 feet. The ship accelerated to attack speed, 16 knots, and moved along the bearing Walker had calculated. At the release point, depth charges rolled off the stern rails at precise intervals, 5 charges in a standard pattern. The charges sank through the grey Atlantic water, pressure increasing with every metre of descent. At approximately 180 meters 600 feet, the hydrostatic pistols triggered. 300 pounds of amatol in each charge detonated simultaneously, creating explosive pressure waves that propagated through the water at roughly 5,000 feet per second. Inside the U-boat, the crew experienced the attack as a series of hammer blows against the hull. The first explosion occurred slightly aft of amidships. The shock wave hit like a physical object, transmitted through water and steel with minimal energy loss. Light bulbs shattered, gauges cracked, men were thrown against bulkheads. The boat rolled violently to starboard, then back to port as successive explosions detonated around it. The commander, gripping a handhold in the control room, felt the impacts with visceral horror. Depth charges were not supposed to reach 600 feet. Every engagement he had survived, every tactical lesson he had learned, every briefing from naval intelligence, all suggested that 600 feet was safety. But these explosions were close, dangerously close. The pressure waves felt identical to depth charges detonating at 300 feet, the standard attack depth he had experienced dozens of times. His mind raced through possibilities. Perhaps the British had developed new weapons. Perhaps his depth gauges were malfunctioning, showing 600 feet when the boat was actually shallower. Perhaps, and this thought was most terrifying, the entire tactical doctrine he depended upon was wrong. If the British could reach 600 feet, no depth was safe within the operating limits of a Type WWII. The chief engineer reported damage: minor flooding in the stern torpedo room, hydraulic pressure loss in the stern planes control system, electrical shorts in multiple circuits. The boat was controllable but wounded. The commander ordered deeper descent, 650 feet, pushing beyond safe operational limits. If 600 feet was no longer safe, perhaps greater depth would provide protection. The hull groaned under the increased pressure. Rivets wept streams of water. The crew worked frantically to shore up leaks while maintaining silence. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. HMS Starling maintained contact through the first attack. Walker studied the ASDIC returns, noting changes in the submarine's depth and speed. The boat was diving deeper, exactly as he anticipated. He calculated the new depth at approximately 650 feet, near the maximum operating depth for a Type 7C. The submarine was wounded. The attack had scored damage but still mobile. Walker ordered a second attack, this time from HMS Woodpecker. The depth charge settings were adjusted to 700 feet, deeper than any previous attack Walker had conducted. Woodpecker moved into position, guided by Starling's continuous ASDIC bearing. The attack run proceeded with mechanical precision. 8 depth charges released in quick succession, sinking rapidly toward the target depth. The U-boat commander heard Woodpecker's engines through the hull, the distinctive thrashing of propellers at high speed. He knew what was coming. His boat was already at maximum sustainable depth. The hull was stressed to engineering limits. Diving deeper risked catastrophic structural failure even without depth charge detonation. He made the calculation every submarine commander dreaded: remain at depth and hope the charges missed, or risk hull collapse by diving deeper. He chose to maintain depth, trusting that 700 feet exceeded British depth charge capabilities. The choice was based on intelligence assessments, on previous combat experience, on the fundamental belief that German engineering provided a margin of safety. He ordered the crew to brace for impact. The depth charges reached 700 feet and detonated. The explosions were closer than the first attack, the pattern more accurate. One charge detonated less than 50 feet from the pressure hull. The shock wave struck with devastating force. In the control room, the pressure gauge for the stern ballast tanks shattered. The depth gauge cracked across its face. The boat rolled 45 degrees to port before recovering. Men not secured by handholds were thrown across compartments. In the engine room, a seawater pipe fractured, sending high-pressure spray into the compartment. The lights failed completely. Emergency lighting activated but provided only dim red illumination. The chief engineer reported catastrophic damage. Major flooding in the stern compartment, complete loss of stern plane control, electrical fires in 2 locations, pressure hull integrity compromised with water entering through multiple points. The boat was losing depth control, sinking slowly despite attempts to blow ballast tanks. The commander faced the decision every U-boat captain hoped to avoid. His boat was mortally wounded. Remaining submerged meant sinking below crush depth and certain death for all 44 crew members. Surfacing meant exposure to British guns, probable capture, but possible survival for at least some of the crew. The calculation was simple, but required abandoning everything he had fought to protect: the boat, the mission, his freedom. He gave the order. Auftauchen. Surface. Emergency procedures activated. All remaining compressed air was blown into ballast tanks. The boat began rising, slowly at first, then accelerating as buoyancy overcame the weight of flooding water. The ascent was uncontrolled. The damaged stern planes could not maintain trim. The boat tilted sharply bow up as it climbed toward the surface. On HMS Starling, the ASDIC operator reported contact rising rapidly. Walker ordered his ships to hold fire, anticipating a surfacing. He wanted prisoners for interrogation, intelligence about German capabilities and tactics. His gun crews trained, weapons on the position where the submarine would surface. The U-boat broke surface at a steep angle, bow rising 15 feet above the waterline before crashing back. Water poured from the conning tower as hatches opened, and crew members began emerging. Some were wounded, bleeding from impact injuries sustained during the depth charge attacks. Others were in shock, moving mechanically, their faces blank with the realization of defeat and survival. Walker's ships closed quickly, guns trained but not firing. The U-boat crew abandoned ship, jumping into the cold Atlantic water. Starling and her consorts launched boats to recover survivors. 41 of the 44 crew members were pulled from the water alive. The U-boat settled lower in the water, flooding through damaged compartments, and sank stern first within 20 minutes of surfacing. Walker watched it disappear, noting the time and position for his after-action report. The German survivors pulled aboard HMS Starling were in various states of shock and injury. Walker ordered his medical staff to treat the wounded immediately. The uninjured prisoners were separated for initial interrogation while still disoriented from the trauma of their sinking. Royal Navy intelligence officers understood that the immediate aftermath of a sinking provided the best opportunity for gathering information before prisoners had time to recover their composure and remember their security training. The U-boat commander, physically unharmed but psychologically devastated, was questioned first. Through interpreters, he described the attack in detail, the depth his boat had reached, the unexpected detonations at 600 feet and 700 feet, his disbelief that British depth charges could function at those depths. He had commanded U-boats since 1940, had survived multiple depth charge attacks, had been decorated for successful patrols. His confidence in German tactical doctrine had been absolute. The interrogation revealed the extent of German miscalculation. The commander confirmed that German naval intelligence assessed British depth charges as having maximum effectiveness at 500 feet. Training emphasized diving to 600 feet or deeper as the primary survival tactic when under attack. No information had reached operational U-boat commanders, suggesting that Allied depth charge capabilities had changed. The intelligence failure was complete. Walker's after-action report documented the engagement in precise detail: the ASDIC contact, the estimated depths, the depth charge settings, the submarine's behavior, the successful sinking. The report was forwarded through naval channels to the Admiralty's Anti-Submarine Warfare Division. Analysts noted the confirmation that deeper setting depth charges could engage U-boats at their maximum operational depths. The tactical implications were significant. German submarines could no longer escape destruction simply by diving deep. The engagement on February 19, 1943, was not unique. Throughout the spring and summer of that year, similar encounters occurred across the Atlantic. U-boats diving to evade depth charge attacks found that their traditional sanctuary at 600 feet was no longer safe. Depth charges detonated at depths German commanders thought impossible. Boats that should have survived by diving deep were damaged, forced to surface, or sunk outright. German naval headquarters began receiving reports of these encounters through survivor interrogations and intelligence intercepts. By mid-1943, it became clear that Allied anti-submarine capabilities had evolved significantly. The tactical advantage that deep diving had provided was gone. U-boat commanders faced a strategic crisis. Their primary defensive technique had been neutralized. The psychological impact on U-boat crews was severe. Submariners already endured extraordinary stress, confined spaces, contaminated air, constant danger, awareness that depth charges could arrive without warning. They depended on their boat's diving capability as protection, as the margin that kept them alive. When depth was no longer safety, when no depth within the boat's operating envelope provided protection from Allied weapons, the psychological foundation of U-boat operations cracked. Morale declined throughout the U-boat force. Experienced commanders who had survived multiple patrols found themselves questioning tactics that had kept them alive for years. New commanders, already facing the highest mortality rate of any German military service, learned that the defensive techniques they were taught in training were obsolete. The knowledge spread through the submarine fleet. The British and Americans could reach you anywhere you could dive. German naval engineering attempted to respond. Plans were developed for submarines capable of diving deeper. The Type XXI, with design depth of 900 feet, was pushed into accelerated development. But the Type XXI would not enter service until 1945, too late to affect the war's outcome. Existing boats, the hundreds of Type 7 and Type 9 submarines still operational, could not be retrofitted for deeper diving. Their pressure hulls were built to specific tolerances that could not be modified. The statistical record of the Atlantic campaign reflects the impact of improved Allied anti-submarine capabilities, including deeper setting depth charges. In 1942, German U-boats sank approximately 6 million tons of Allied shipping while losing 87 submarines. The exchange rate favored Germany. Each lost U-boat cost the Allies roughly 69,000 tons of shipping. In 1943, the balance shifted dramatically. Allied shipping losses declined to approximately 3 million tons despite more U-boats being at sea. German submarine losses increased to 243 boats. The exchange rate reversed. Each lost U-boat now cost the Allies only 12,000 tons of shipping. By 1944, German losses exceeded 300 submarines, while Allied shipping losses dropped below 1 million tons. Multiple factors contributed to this shift. Improved radar allowed escorts to detect surfaced U-boats at night. Long-range aircraft closed the mid-Atlantic air gap where submarines had previously operated beyond air coverage. Convoy escort tactics improved as experienced commanders like Walker trained new escort groups. Intelligence from broken German codes allowed convoys to route around known submarine concentrations. But the neutralization of deep diving as an effective defense was fundamental. U-boats that could no longer escape by diving deep had to adopt alternative tactics, all of which were less effective. Some commanders tried remaining at shallower depths, accepting depth charge risk in exchange for better maneuverability. Others attempted to surface and fight convoy escorts with deck guns, a desperate tactic that usually resulted in the submarine's destruction. Still others tried to avoid contact entirely, hiding during daylight hours and moving only at night, which reduced their effectiveness as commerce raiders to nearly zero. The human cost was staggering. Of the approximately 39,000 men who served in the German U-boat force during World War II, approximately 28,000 died a mortality rate of 72%, the highest of any German military service. The majority of these deaths occurred after the tactical balance shifted in 1943. U-boat crews continued operating despite knowing the odds of survival were minimal. They obeyed orders, maintained discipline, and sailed on patrols from which most would not return. Commander Walker continued hunting submarines through 1944. His second escort group became one of the most successful anti-submarine formations in the Royal Navy. Walker personally was credited with sinking 20 U-boats, more than any other Allied anti-submarine commander. His tactics were studied and adopted throughout the escort forces. The creeping attack technique became standard procedure. The use of coordinated group attacks replaced single-ship methods. Walker did not survive to see the war's end. He died of a cerebral hemorrhage in July 1944, at age 48. Medical officers attributed his death to exhaustion from sustained combat operations. He had pushed himself and his ships relentlessly for 4 years, conducting patrol after patrol with minimal rest. The strain had accumulated beyond his body's capacity to recover. The Royal Navy gave him a funeral with full military honours, recognizing his contribution to victory in the Atlantic. The U-boat commander, captured by Walker in February 1943, spent the remainder of the war in a prisoner of war camp in Canada. After repatriation to Germany in 1947, he returned to civilian life and never spoke publicly about his wartime experiences. In the 1970s, a military historian located him and requested an interview for a study on U-boat tactics. The former commander agreed to speak on condition of anonymity. During the interview, he described the moment when depth charges detonated at 600 feet as the worst experience of his life, worse than the actual sinking, worse than being captured. For years, he explained, he had trusted his boat's diving capability. He had believed German engineering and German intelligence. The realization that he had been wrong, that the protection he depended upon was illusory, shattered something fundamental. He had sent men into situations of extreme danger based on assumptions that proved false. That knowledge, he said, was a burden he carried for the rest of his life. The development and deployment of deeper-setting depth charges represents a small but significant example of how industrial capacity and technological adaptation determined outcomes in World War II. The Allies identified a tactical problem, U-boats escaping destruction by diving deep, and developed a technical solution. The solution was not revolutionary, not a radical breakthrough, but an incremental improvement to existing weapons. Stronger hydrostatic pistols, reinforced casings, better quality control, these mundane engineering refinements had profound tactical consequences. The German response, or rather the lack of effective response, illustrates the constraints that limited German military effectiveness by 1943. German engineers understood that U-boats needed greater diving depth to counter improved Allied weapons. They designed submarines capable of those depths. But Germany's industrial capacity could not produce those submarines in sufficient numbers, while simultaneously maintaining production of aircraft, tanks, artillery, ammunition, and all the other material required to sustain operations on multiple fronts. Strategic choices made years earlier foreclosed options available in 1943. Germany had chosen to wage war against the Soviet Union while still engaged with Britain. That decision committed resources to the Eastern Front that might otherwise have gone to U-boat construction. Germany had failed to mobilize its economy for total war until 1943, allowing the Allies to build industrial advantages that could not be overcome by superior tactics or fighting spirit. The men who served in U-boats paid the price for these strategic failures. They were highly trained, disciplined, technically competent crews operating equipment that was adequate in 1940 but obsolete by 1943. They employed tactics that had been effective against early war Allied escorts, but were increasingly suicidal against the escorts of 1943 and 1944. They continued fighting because military discipline and national loyalty demanded it, not because they believed victory was possible. The Allied submariners and escort crews who fought them also paid a price. Depth charge attacks were imprecise weapons. Many attacks produced no results. Hours of patient stalking could end with the submarine escaping. The frustration of knowing a U-boat was nearby but being unable to achieve a kill wore on crews' morale. When attacks succeeded, when depth charges detonated close enough to force a submarine to surface, the aftermath was always grim. Pulling German survivors from the water, seeing their wounds, their exhaustion, their relief at survival mixed with shame at capture, these experiences affected Allied sailors deeply. Commander Walker's success came at personal cost beyond his eventual death from overwork. The responsibility of command, the necessity of ordering attacks that killed men, the accumulated stress of years at sea all took psychological toll. His letters to his family, preserved in British naval archives, reveal a man increasingly aware of the human cost of submarine warfare. He took no pleasure in killing German sailors. He understood that they were professional seamen doing their duty, much as he was doing his. But duty required their destruction, and he pursued that duty with relentless efficiency. The hydrophone operator who first detected the U-boat that February afternoon went on to serve in escort vessels throughout the war. In 1992, at age 71, he was interviewed for an oral history project on the Battle of the Atlantic. He described hearing the U-boat's engines through his hydrophones, tracking the contact as it dove deep, listening to the depth charges detonate. He remembered the silence that followed, the wait for sounds that would indicate whether the attack had succeeded. Then came the noise of ballast tanks blowing, the rushing sound of a submarine emergency surfacing. He knew then that they had won the engagement. He also knew that men had died or been wounded in that steel tube beneath the water. The memory, he said, remained vivid after nearly 50 years. Some experiences, he explained, stay with you regardless of time past. The tactical lessons from encounters like the February 19th engagement influenced anti-submarine warfare for decades after World War II. The principle that weapons must evolve to counter enemy defensive adaptations became fundamental doctrine. During the Cold War, when Soviet submarines operated at depths far exceeding World War II capabilities, NATO navies developed weapons systems capable of engaging targets at those depths. The pattern established in the Atlantic campaign, identify enemy capability, develop counter-capability, deploy at scale, remained the template for anti-submarine warfare through the end of the 20th century. For historians studying World War II, the story of deeper-setting depth charges illustrates how seemingly minor technical improvements could have strategic consequences. The history of the war is often told through major battles and decisive campaigns, but victory in the Atlantic came through accumulation of small advantages: better radar, improved tactics, enhanced weapons, superior intelligence, greater industrial capacity. No single factor was decisive. Together, they created conditions where German U-boats could not operate effectively, where supply lines remained open, where American men and materiel crossed the Atlantic to support operations in Europe. The U-boat commander who surfaced his damaged submarine that February afternoon made the right decision. His boat was sinking. His crew was in danger. Surfacing saved most of their lives. But the decision also symbolized a larger truth that German naval leadership was beginning to acknowledge. The U-boat campaign had failed. Allied countermeasures had neutralized the submarine threat. The tonnage war, the attempt to sink ships faster than the Allies could replace them, was lost. Germany could not prevent the build-up of Allied forces in Britain for the eventual invasion of Europe. The survivors pulled from the Atlantic that day entered prisoner-of-war camps and remained there until war's end. They were among the fortunate ones. Most U-boat crews who put to sea in 1943 did not survive. They went down with their boats, killed by depth charges or crushed by pressure when damaged hulls failed, or drowned when flooding overwhelmed pumps and ballast systems. Some died quickly in catastrophic explosions. Others died slowly in disabled submarines settling toward the ocean floor, knowing death was coming but unable to prevent it. The men who heard depth charges detonating at 600 feet, who realized in that moment that their deepest refuge was no longer safe, experienced terror that few can imagine. That terror, multiplied across thousands of encounters throughout the Atlantic campaign, was part of the price paid for Germany's strategic decisions and military ambitions. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.